in this examples, we're going to be factoring. We're going to start with question number 12. And the directions are factor, simplify, completely. Okay, so you're going to ask yourself the first question. Is there a GCF? Always. The first question is there a GCF? So you're going to look at the numbers 60, 44, and 48. And you're going to ask yourself, is there a GCF? Do they all have a factor in common that I can pull out, take out of the expression? In this case, yes. They are all divisible by 4. First, they're all even. So you can start by saying, do they all divide by 2? And yes, they do. Then check the next one. So before, in this case, they all simplify by 4. Now, you want to also check, do the variables simplify? Well, there's no variable here. So there's no GCF for variables, okay? So it's just 4. So then you have 4, pull it in the front. 60 divided by 4 gives you 15x squared, plus 11x minus 12. Okay, then you have to ask yourself, how many terms? Inside here, there's 3 terms. So you want to factor by grouping using the AC method. Okay, so you're going to say 15 times 12. And that gives you, I have it somewhere over here, gives you a quite a bit large number, 180. Then you want to find the factors of 180. I did it ahead, and there are a lot of them. I'm going to give you the easiest one, 1 to 180. You have to find the rest, but once you do, you're going to end up with, if I'm correct, where did I put it at? 9 and 20. Okay, 9 times 20 gives you 180. 9 minus 20 gives you the 11. And then you ask, well, how does she find that? Well, I went to, I did 180 divided by 2, gave you something. 180 divided by 3, so on, 180 divided by 4, until you got to the 9. Now, again, you want to look at the numbers that you're working with so you don't take so much time in doing this, because sometimes you have a lot of factors, so you have to do this a long time. So you want to go around. If 2 doesn't go, maybe go to 6, maybe go to 7 or 8, and so on, okay? So in our case, in this, it's 9 times 20. So that 9 times 20 will replace the 11x. So I'm going to rewrite it. And just so we don't forget something very important, I'm going to put my GCF. I put this little arrow to make sure it's part of my answer. So I have to have it in the answer. Sometimes you're working with this and you forget it. Okay, so then I have 15x cubed plus 20x, positive times negative, negative 9x minus 12, split in the middle. What do these two have in common? 5x. So I write in the front 5x. Divide this gives me 3 plus 4. Bring my negative down. What does this have in common? 3. Negative 3. Since this is a negative, you're going to say my GCF is a negative. So then I have negative 9x divided by negative 3 gives you positive 3. Negative 12 divided by negative 3 gives you positive 4. The cool thing about the grouping is that if this right here and this right here is not the same, you have to go back and double check your work. But in this case, it is the same. Therefore, we get a check mark. Oops, check mark. That looks enough. Check mark. Okay, good. So between this term and this term, what is in common? The 3x plus 4. Pull that out, 3x plus 4. What are you left with? The leftovers, 5x minus 3. And you want to say you're done, but then you go back and say, wait a minute, my arrow is reminding me something. Yes, it's reminding you your GCF that you took out from the beginning, and that it has to be part of the final answer. So you write it right here in the front. And for the example number 12, this right here is your answer. Now the next example compared to number 12 is much easier. But let's just, let's work it out. So, first question, is there a GCF? In this case, there's no GCF. Then this is a 1, so there's no GCF. This one has no variable, so no. So then automatically you go and say 1 times 9 gives you 9. Factors of 9, that will subtract or add to 6. And that's going to be 3 and 3. So we're going to say c squared plus 3c plus 3z plus 9. Okay. Split in the middle. What this has in common? A z. We're going to pull it out. Z plus 3. Here a 3. Here a 3. Z plus 3. Right? What this has in common? A z plus 3. Left over is z plus 3. And then you ask, wait a minute, they're the exact same thing. It's weird that I did something wrong. No, you did not do anything wrong. Or I didn't do anything wrong. So you're going to rewrite and say z plus 3 square. There's 2 of them, so it's square. And what does this tell you? Is that the z squared plus 6z plus 9 is a perfect trinomial. So you didn't have to do this right here. You didn't have to. Okay? If you were to recognize from the beginning that this was a perfect trinomial, you can simply write the answer. You can skip all the steps and go over here. How you could do that? Well, you have to double check. You ask, is this a perfect square? Is z squared a perfect square? Yes. Square root of c squared is z. Okay? Is the last term a perfect square? Yes, it's 9. 3 times 3 gives you 9. Square root of 9, 3. So 3. Okay? And then it says, multiply this times 2. If this multiplication gives you the middle term, then you have perfect square trinomial. And yes, 6z. Okay? The signs have to be positive and positive, or negative and positive, for it to be a perfect square trinomial. Now, sometimes I do tell the students that if you're not able to recognize it, simply do the AC method. You will arrive to the exact same answer. If you are able to see the trinomial, do the check and make sure you have the correct signs. You can actually write it right here. Okay? Z plus the 3 square. Okay? You want to double check, FOIL, double distribute this right here, and you will get back to the original. Okay? You have choices. For the question number 14, we're going to start the same way. Is there a GCF? You can look at it, no GCF. How many terms? In this case, we only have 2 terms. When we have 2 terms, we want to factor it using the difference of perfect squares. Now, in order for me to check if this is the difference of perfect squares, I need to have a few things. The first term has to be a perfect square. The last term has to be a perfect square. And in the middle, it has to be a difference. Difference. Hopefully I spelled that right. And 25 is a perfect square. X squared is a perfect square. 64 is a perfect square. And yes, it's a difference in the middle, right? So what do? You open 2 sets of parentheses. Okay. You ask yourself, what's the square root of 25? 5. 5. Okay. What's the square root of x squared? X. X. Has to always be plus or minus plus. Different signs. Okay. Square root of 64, 8. 8 and 8. And that is your answer for that example. So the answer for question 14, the answer for question 13, and the answer for question 12.